Hello everyone. So today is going to be our day 12 of the DSC challenge that we took. And the question that we're going to solve today is inversion of array, right? So this question I couldn't find on lead code. So I think we'll have to go forward with coding ninjas only, right? So this is the question. This is the question, right? That for a given array slash integer array list, array of size n containing all distinct values, find the total number of inversions that may exist. An inversion is defined for a pair of integers in the array slash list when the following two conditions are met. A, a pair array I and array j is said to be an inversion when array of I and is greater than array of j and I is less than j. Great. So let's understand this question on Excalibur. Let me probably take this example. That would be much better. Yeah, here, right? So this is an example. This is n, and this is our array, straight black, right? So and you need to find, okay, what you need to do is you need to first see that hey, I am starting from this position. All right, this is two. Is two greater than five? If my I is standing at here and my j is standing at here, is 2 greater than 5? You will say no. J greater than j. Is 2 greater than 1? Yes, you will say. So 1 plus 1, 1 count has been added with 1, right? So 1 has been incremented. Now j goes here. 3 does not form a pair with 2 since 2 is not greater than 3. J goes here again, not a. I comes here. Does 5 and 1 make a pair? Yes. Does 5 and 3 make a pair? Yes. Does 5 make a pair with 4? Yes. Great. I comes now here. Does 1 and 3 make a pair? No. 1, 4, no. 3 comes here. Does 3 make a pair with 4? You will say no. The Is there anything else left? No. I comes here. There is nothing left, so you will break up. How many pairs could you make? One, two, three, and 4. Let's see the answer. So there were 4 possible. Yeah. We have a total of 4 pairs which satisfy the condition of inversion 2, 1, 5, 2, 1, 5, 1, 5, 3, and 5, 4. Right? So this is the entire answer for it. So this is the brute force, right? I hope you already know that we are discussing the brute force. So let's write the pseudo code. It's gonna be fairly simple. So we'll start our I from it will start from 0 and it will go till n, right? We'll have another, let's define our uh, count to be equal to 0, and we'll define our j which will start from I plus 1. Now why is it not starting from 0? Because we cannot, here it is, the condition says that I should be less than j. Where is the condition? Yeah. So second condition is I should be less than j, and it cannot be equal to I. So j cannot be equal to I, so we are not starting from j is equal to I, we are starting from j is equal to I plus 1, and we'll go till n again, right? And we'll say that if my array of I is greater than array of j, um, just increase the count, right? And simply return my count, right? So this will give you the entire um, the counter of it, and thus basically it will give you what's the how many pairs can you make which satisfy the inversion situation. So the time complexity is again fairly simple. It will be O of n square, since we are running almost um, this loop will run entirely from 0 to n, so O of n. And this loop, although it doesn't run exactly like till n, but it is almost equal to O of n. So we'll take this. And space complexity is going to be constant since we are not using any extra space, right? So this is done. You don't need, I mean, obviously, when you will code it up, you will notice that what is the constraints given are, can be find. Yeah, constraints are 10 to the power 5 and 10 to the power 2, right? Will give you 10 to the power 10, and this will be TLE. So obviously we need to figure out something, some of a better approach. Now, what is better than O of n? For it can either be O of n or it can be O of n. It could be n log n, right? So this is better and this will be the best solution, right? But uh, I you will notice that you will not be able to find any solution for O of n here. Let's try to think of O of n log n, right? Let's try to think there. Let's try to think there. Now, I'll give you two arrays, okay? Just we are now at optimal part, just to mention, right? Let's take two examples, okay? Take two arrays. Let's take two arrays, 2, comma 3, comma 5, comma 6, and one array will be looking like 2, comma 2, comma 4, comma 4, comma 8, right? Let's take this example. I took this example from Scriber only, so you can obviously find out there as well. Okay, you have been given two arrays, right? Num1 and array2, or array1 and array2, right? Can you notice that these arrays are sorted? These arrays are sorted, right? These arrays are already sorted. Great. So we need to find out something from this pair only, from these two arrays. Let's try to figure out, and assuming that array1 and array2 separately are part of one single array later on. Later on, we'll get to it. But assuming now that we just have two arrays, two separate arrays, can we find one element from this and one element from this, which can make a pair? Let's see. Does Let's start from here and let's start from here, right? Let's start from here. Can two make a pair of two with two? No, because obviously you will know that here it is given that array of I, where is it? Yeah, array of I should be greater than array of j, not equal to, right? So you just simply write down 2 here and you will move to this position, right? Great. Can 3 form a pair with 2? You will say yes, 2 it can make. So you will add, so let's just say your counter was 0 initially, you will add a plus 1. But adding a plus 1 will um, you'll make you lose on lot of elements, right? So basically again then you will be here, because you will lose when you will. So basically when you've already made a pair with it, you will either write it down here and then you will move to the next pointer, but you don't need to do that. So what you can say that, hey, the array is already sorted, so if I can make a pair with that element, obviously all the elements that are greater to me will can form a pair with that too. So if 3 can make a pair with 2, can't 5 and 6 make a pair with 2? Obviously you will say yes. So I'll not add 1, I'll add 1, 2, 3. So I'll just say, sorry, so I'll just add plus 3 to it, because 3 can make a pair, 5 can make a pair, and 6 can make a pair. Great. I'll just write this down 2 and I'll move to here. My J pointer is somewhere here. Great. Can 3 make a pair with 2 again? You will say yes, it is. And can all these things, all elements greater than me can make a pair? You will say, hey, obviously. So plus 3 again. Great. You will again write down 2 here. Move to J, which is 4. Can 3 form a pair with 4? You will say no, no, it cannot. So you will just write down 3 here and you will probably move to this point. Can 5 form a pair with 4? You will say yes, it can. Should I add a plus 1? No. Why? Because if 5 can make a pair with 4, can't the elements greater than 5 make a pair with 4? Obviously it can. So I'll just add plus 2, because there are 5 and 6, the next element, right? Because you cannot, there is no other element. So I'll just add plus 2. Great. I'll write down my 4 here. My J moves to this point. Again, can 5 form a pair with 4? You will say yes, and then you will add plus 2 to your answer. Great. 4 written here, my J moves to 8. Can 5 form a pair with 8? You will say no, it cannot. My I moves here, and obviously I'll write down my 5 here. Can 6 form a pair with 8? You will say no, it cannot. So simply write down 6 here, move my 8 to this. Now it is out of bounds. So I'll just simply write all the elements that are left in this second array. So 8. Can you notice something? Can you notice something? These two arrays, right? These two arrays now form another sorted, right? Another sorted array. And this will be your final answer, right? Not final answer for this question particularly, but I'm saying that this will be your final array, right? So you will notice that we have already added all the elements. We have already formed these many pairs. So 3 plus 3, that is 6. So 6 plus 4, that is 10. We could form 10 pairs out of these all elements when they were not sorted to each other, when they were not exactly sorted to a particular um, what do you call it, to a particular final array, right? Great. So you know, now you know my intuition, right? That I am going to use something called as dividing it, and then I'm going to conquer it. And I hope you already know, in the previous video, we discussed word sort. Was it running on the same ideology that divide and merge, divide and conquer? Now, why did I use conquer word there? I use it for this particular question. We are conquering something. We are achieving something out of it. Either we are merging it, that is something that is achievable, and that is going to be achieved for merge sort, right? But for this particular question, we are achieving something, that is we are incrementing our count, we are incrementing our pair, we are finding the pairs that could uh, possibly form an inversion pair, right? An inversion pair which is where I is less than j and array of I is greater than array of j, right? So this is something that we are conquering out, right? Great. So I hope you already know by now that I am conquering something out, right? Let's try to add one more example, and now we'll move to recursion, right? So this is an example given to you, right? This is an example given to you. From brute force, you could find out that this could make so 5 is going to make pair with all these, and I mean we'll find out with how many pairs can it be, So I'll say that hey, my count is going to be 0, right? Great. Let's kind of divide. What is my division? So 5, 4, 3 will come here. 5, 4, 3 comes here. As you already know that we will divide it with from mid and 1. So where is my, this is my low, this is my high, and where is my mid? Mid is somewhere here. So till from low till mid, low till mid, and mid plus 1 till high, right? Again, we'll divide this. Okay, we'll divide this. What is this? This is going to be 5, 4, and this is going to be 3. Okay, we can make it simultaneously. We can divide it to 2, and we could make it to 1. Great. Um, can we make it further? Yes, we can. So 5 and 4. Great. What I'll do is, I'll now see, can this be further divided? You will say, no, this we have reached our base, right? These two are separate arrays, right? These two are separate arrays. Now, can we, can we implement the logic that we discussed here? Can we implement a logic that we discussed here? Let's try to do that. Let me put my I here. Let me put my J here, right? Basically my left pointer here and my right pointer here. Great. We'll get to the code and we'll know like where to put your L and where to put your right pointer. But okay, can 5 form a pair with 4? You will say obviously Rohan, it can, right? So if 5 can make a pair, every element after 5 can make a pair with 4, although there is one. But I mean, I hope you get my intention, right? So I'll say just add plus 1 to it, right? Because there is no other pair. So I'll just write down 4 here, and I will move my right pointer here. So is there any element, though it is out of bounds? So what I'll do is I'll write down everything that is there in my left part, everything that is there, right? Great. So now this becomes 4 and 5, right? Great, great. Can now you can notice at this point of time, now I have 4, comma 5. Is it sorted? Yes, it is sorted. Is 3 also sorted? Yes, it is. Can 4, if my left pointer is here and my right pointer is here, can my 4 form a pair with my 3? You will say yes. So every element after it can form a pair with 3, because obviously if 4 can make it, then obviously everything that is greater than 4 will form a pair. So I will add plus 2 to it, plus 2, right? And I will just simply write down my 3 here, okay, right? My 3 here. And what I'll do is I will what I'll simply do is I will move my right pointer to here. I will move my right pointer to here. Great. Um, so if I put my right pointer here, so I have to write 5 here as well, right? 5 here as well. And this will go back. These things will go back, right? So what does it become? It becomes 3, 4, 5, right? Can 2 form a pair with 1? You will say yes. So everything that is there after 2, you will form a pair with it. So if my right was here and left was here, right will be put here, and you will say that hey, you cannot do anything. So just write down 1. You already wrote 1 here. Simply write down 2 also here and just move back. Now what does this become? This becomes 1 format. So you will notice that we have already found out pairs on the left part of this uh, array, and we have found out all the pair on the right part of this array. But we haven't found out from these two things, obviously. So we have done to the child array. We have already found out from the child array, but the parent array we haven't still found out. Great. Let's do one thing. Let's let's start our left from here and our right from here. Can 3 form a pair with 1? You will say yes. Should I add all the other elements? So yes, I will add plus 3 to it. I will write down my 1 somewhere, 1 here, and I'll move forward. My right is now here. Can 3 form a pair with 2? You will say yes. Again, I will add plus 3 to it. So right comes here, and obviously it is now out of bounds. So you will notice that I've written 2 here, and now I will write here, I will write this, and I will write these three. Isn't this the sorted array? Isn't this what we achieved in the previous question, that was merge sort, right? Merge sort is done, and you will notice that 1 plus 2, that is 3, 4, 4 plus 6, that is 10. We could make out 10 pairs, 10 pairs from this thing, 10, 10 pairs from this thing, right? So these elements, so if I use my brute force, can 5 form a pair with 4? You will say yes. Plus 3 plus 2 plus 1. Can 4 form a pair with 3? You will say yes. Plus 1 plus 1 with 1 also. Can 3 form a pair with 2? You will say yes. Uh, can 3 form a pair with 1? You will say yes. So plus 1 plus 1. Great. Can 2 form a pair with 1? You will say plus 1. How many are these? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this was also 10. So 10 pairs were found out. I hope you understood, right? I hope you understood what we did. Great. Now let me do one thing. Let me copy this. Or let's say if I copy this, not this one. I don't need it. I don't need this. I'll just simply say 5, comma 4, comma 3, comma 2, comma 1. Right? And I'll just make it here. I'll delete this part. Great. When I divide it, right? It was 5, it was 4, it was 3, it was 2, it was 1. Great. My low was where? Where is my low? Low was here, right? Where was my high? My high was here, right? Where was my mid? So low is here, high is here, and mid is somewhere here. So this is something mid plus one, and this is my mid, correct? Correct. So to count, so assuming that now this is sorted and this is also sorted, how many pairs can 3, 4, 5, and 1, comma 2, 3? How many pairs can 3 form with my right pointer that is here? So if my left is here and my right is here, right? It can form. So I'll say that hey, count is nothing but mid plus 1. I am at this position minus my low position. So where is my low? Low is here. Low is at 3. So if this can form a pair, obviously these can form a pair. And what is my mid right now? What is my mid plus 1? It is 1, 0, 1, 2, 3. It is 3 minus what is my low? Low is 0. So didn't we add plus 3 when we were at uh, when we were at 3? So where is it? Yeah. At this point, when we were at 3, how many pairs did we add? Can you see here? Can you see here? I think, yeah, this was the part, right? This was the part where we added 3. Great. And when we are at this, now my L is here, my low is here, right? So if I say that, hey, can four form of pair? Actually, we don't need to go till 4, but I hope you understood. So we'll simply just say that mid minus low plus 1. These many pairs can be added. These many counts can be added if my 3 can form a pair. So these elements also will form a pair with my 2, right? So I'll just simply write 2 here, and I'll just then compare it with 1. What is my right here? Right is this, and what is my mid plus 1? This is this. So mid plus 1 minus low. If 3 can form a pair with 1, then 4 and 5 obviously will make a pair with 1. Great. Let's do something. Let's try to first implement our brute force, right? Or should we do that? I don't think we need to do that. We have already written our pseudo code. Let's simply, let's simply initialize a counter variable to the global level, right? Let, not int, sorry, let, right? Let count is equal to this. And let me copy my whole merge sort function. So if this is this, yeah, I hope you can see the pages. You can see the code that this was our merge sort, right? When was when was the point when I achieved that my left is greater than right? When my left part is greater than right. At this level, sorry, at this position, we know that my array of left is greater than array of right. Shouldn't we add something? Should we add something to our counter at this point, right? Yes. So my counter will be equal to nothing but mid plus 1 minus low. This is what we discussed, right? Or you can say mid minus 1 plus low or whatever, right? I hope you understood the point, right? Let's try to console this. Let's first call the merge sort here where we'll pass array, we'll pass. Oh, I have written these two lines for you already. So because in this particular function we had to take the array and we had to take the input basically from the user. So we did that. So I've already written these two lines. It is already mentioned in the comment like how you can take the array and how you can take the n. I've just added this another map function which will convert every element that is a string or a character to this plus icon, not icon, this plus thing will just convert it to what do you call the number. It will convert it into number, right? So 0, and what is my high? My high will be nothing but n minus 1, right? And let's simply console log count. Let's try to run this. Okay, there is some problem. Okay, 36. Why is that so? Why? Why left is this? I am console. This is my counter. This is my count. I am just adding something to it. Made, what is this then? What is the problem here? Let's try to run it again. Okay, let's take this example and see 3 to 1. The correct answer should be 3, but we are getting 3 only. So there's no problem in this situation. Let's try to figure out for this. Let's try to run for this. So desired output is 4, but we are getting 8. Let's try to figure out what's the problem. Oh, I'm really sorry. Actually, I did not need to use my low here. I needed to use my left here because because you will notice that we will be pushing, our left is here, our right is going to be here. That is mid plus one, and our mid is going to be here. Actually, I confused my L with my low only. So low is, this is not low. This will be going to be left, right? My left will start from here, then it will move forward, right? As I explained to you, did I explain to you here? I think I did, yeah. So in this, basically in this tree, we were moving our left. This is our left, this is our right, right? So we are moving our left forward and this left forward, right? So actually I needed to count from mid minus left plus low, right? So let me try to run it again. This gives me desired output. Let's try to run this example as well, and we are getting solved. Great. Let's try to submit it, and we will notice that this is accepted. Great. Great. So basically, this problem has been solved. But the point is, we don't usually, can I move it? Yeah, we don't usually take a global variable for it, right? We don't usually make a global variable for a count. We need to somehow pass it into our merge sort only. Now, how can we do that? How can we do that? Let's remove this. Let's initialize, let's initialize our counter in our merge sort only, right? So every time my merge sort is called for the left part, I'll just add it, right? Every time my right part is also merge sorted, I will add it. And when I will merge it, I will obviously add a counter. I will add every time my merge will give me basically my, where am I calculating that count? I am calculating in my merge, right? I am calculating in my merge function. So this will finally give me the final answer. That is the count that we are adding to, and we'll just simply return count. We need to change our base case a little bit. So this is the base case, and we need to return. We just don't need to return from there. We need to return the count from this point, right? Great. Now let's take a count here that is going to be 0. Let's not. Okay, yeah, it doesn't really matter. And this will remain as same, and we will at the end we will just return our count, and let's let answer is, let count of inversion equal to this, and we'll just console it. Great. Let's try to run. Okay, great. This is running fine. Let's try to submit this, and it will obviously run. Great. Except, so you already know that that you need to. So you basically every time when you are given a question, just don't initialize a global variable. Try to implement it in your recursion only. So I could have passed it in my merge sort function. Where in my merge sort, I could have passed a another thing called count. But every time I need to track my count, right? So I that is not a really good idea. We can obviously put a counter here, right? Initialize it in my function only, and whenever the base case is found, we'll return that. Else we'll just increment the count with every every recursion call and finally where am I conquering my count part? I am obviously conquering my count part in my merge solution. So I'll initialize it here and then simply just return my counter, right? This was a short video, but this needed you to understand what how merge sort works. Obviously, now you know if you make two pairs, if basically if you make divide it into two and you get a merged array, you get a sorted array. You need to find that count from that position, right? So you need to check my merge sort video for that. We I hope I've already put it on my YouTube channel, so you can obviously find it from there. So thank you so much for joining in. I'll see you tomorrow with another question. So today, day 12 has been solved. Let's let's write, use, divide, and conquer slash merge sort. Try to conquer. Try to add counts in your conquer part where you will increase your count for every element which will form a pair and every element in the left array after that particular element will form a pair too. So count is nothing but mid minus left plus 1, right? Great. And then return back. Great. Let's try to save it. Great. And let's mark it as done. So we have already done 12 days. We'll start from this thing, search in a 2D array. I don't think it should be that difficult. POW will not be that difficult again because it will, I think POW, power majority element and majority element n by 3 is going to use I guess binary search. So we'll check what how binary search works as well. I'll try when I think search in a 2D matrix also implements binary search. I'll try to make a binary search video for you as well. I'll try to upload it tomorrow only, and then we can probably search in these. In we can start with this array three part, right? Array part three. So I think all these till here, I am sure. Grid unique path. I'll have to read the question. I don't remember. Reverse pair. I don't remember the question, what it says. So I think all these questions will require binary search. And even if not, we will see how these questions go forward. Okay. Thank you so much for joining in. I'll see you tomorrow with another question.